How to use the subnetwork flow scenario with Dynasim. The subnetwork flow scenario is used exclusively with flow scenarios of type generator. It in fact allows to simulate a subset of the network by applying the demand calculated on the whole network. We edited a network that includes 4 crossroads. Red crossroad is named C1, the violet one is named C2, C3, and C4. We have already defined a network scenario named network_C1234, and a flow scenario of type generator which includes all 4 crossroads. We are going to cut out the network in 4 subnetwork, 1 for each junction. To do this we will put the trajectories in layers, layer named C1 for junction 1, layer named C2 for junction 2, etc. First step, I add 4 layers, starting with C1. Then add layers C2. Add layers C3. C4. I go to the Network Scenario Manager. I will add all the new layers to this scenario named network_C1234. I will now switch into layer C1, all the trajectories and elements of the first intersection. I go to Edit Mode. Shift-click left button. Shift the mouse until the displayed rectangle includes all the red trajectories. I switch the layer from base to C1. Now all the selected trajectories belong to the same layer. Unselect the trajectories by clicking in the canvas. I have repeated this operation on junctions C2, C3, and C4. Now, we need to define a network scenario including exclusively trajectories of the first crossroad. The name of the scenario is network_C1. Recall that the scenario parameters were copied from network_C1234. So we will first uncheck all the layers of the new scenario, then add the layers named base and C1. We can now add the new network scenario, named network_C1. Network_C1 becomes the current network scenario displayed in the canvas. You can view the entire network by selecting the network scenario, named network_C1234. I now want to simulate the subnet C1, taking into account the flows calculated on the entire network. We have already defined 2 flow scenarios of type generator, corresponding to the peak hours in the morning and evening. For example, the morning flow scenario includes an OD matrix. For the category VP, I will define a new flow scenario named flow_C, which is of type subnetwork. We must add the scenario before editing its parameters. This field lists all the flow scenarios of type generator that are defined in my simulation model. I want to use the matrices of the flow scenario named flow_C1234 in the morning. The network scenario defines the network on which I will calculate the flow. It is in our case the network encompassing the 4 intersections. Apply changes of the scenario named flow_C. Now, I wish to simulate crossroad C1 in the morning. Now, I'll use the same technique for the second crossroad. I create a new network scenario named C2. The network scenario C2 includes 3 layers. Keep base, uncheck C1, add layer C2. Oops! I forgot to add the data collectors contained in the layer named Joji_C2. Now, I can add the new network scenario. Solely Junction 2 is displayed in the canvas. I use the Simulation Scenarios panel. Using the report files, I will be able to compare flows from the simulation of the crossroad to the ones of the simulation of all the network. Let's add a simulation scenario for the intersection number 2 for the peak hour in the morning. I can add the simulation scenario, combining the violet trajectories of the second crossroad, and a flow scenario of type subnetwork. I switch to calculation state. None of the reports have been calculated following the gray lights, displayed in the report column. Select both scenarios, and then compute the reports. A single replication is calculated to save time. The calculation is done. For the simulation scenario, including all intersections, report files are saved in the directory, location of the Dynasim studies, study name, directory named report, directory of the simulation scenario whose name is obtained by concatenating the names of his network scenario, his flow scenario, etc. The data collected during simulation are formatted in the subdirectory named results. Display the flow at the violet intersection for the simulation scenario compiled with the network scenario named network_2 and the flow scenario named C_. In the case of the simulation limited at the crossroad 2, coming from the east, the expected demand is 750 vehicles. In the case of the complete network, coming from the east, the expected demand is also evaluated at 750 vehicles. The demand is also equivalent between the two models for the other three branches of the violet intersection. Coming from the east, the flow measured during simulation is 731 vehicles in the case of the subnetwork, while it is of 740 vehicles in the case of the simulation of the entire network. This shows that we are facing two different simulation models. The simulated models are stochastic. The values of some parameters, such as the inter-arrival time of vehicles entering the network, are determined according to a random distribution. These stochastic models require multiple replications to get an average number of simulated vehicles converging to the expected demand. We computed only one replication, which explains the differences between the number of simulated vehicles and the expected demand. To conclude, the flows through the second junction are equivalent if we simulate the entire network, or only the intersection. Now, I want to simulate together the two intersections C1 and C2. I add a new network scenario which includes intersections C1 and C2. I name the new network scenario, network_C12. I add a new simulation scenario, including the network scenario named network_C12, and the flow scenario of type subnetwork named flow_C. To summarize, a flow scenario of type subnetwork applies necessarily on a flow scenario of type generator. It is also important to note that the subnetwork of trajectories that we wish to simulate defines a continuous space. In our example, it is not possible to simulate a network consisting only of the two intersections C1 and C4. Et voilà! Thank you for your attention.